Hey guys, so we started working on this game, this breakout game, which is based on the old game like Popcorn, which is the whole idea of the game is you have this pad and they're bold and they're hitting breaks and so on and so on. So what we did so far is to use the input to control this pad. We started by automatically moving it from side to side, and then we changed it to use the keyboard. So now, if I press the keyboard, I can move left and right. But I'm also getting stopped by the walls because we used the limit X, as we can see here, and the limit X helped preventing us from moving beyond the walls. Okay, so we said that in this lecture, in this tutorial, in this video, we're actually going to start and work and look on the use of physics. Okay, because this is kind of a physics-based game. You can do it without physics, but it's basically a physics game. So how would we do that? So first of all, to do that, let me start by creating a ball. Okay, so I'll just right-click here, and I'll create a 2D object, which is going to be a sprite and going to have a circle. And this is a bit big, so let's make it a bit smaller. Okay, and just for the fun, I'll change the color to yellow. Okay, so I picked this ball. I used the inspector to go to sprite render and change the color to yellow. What I'm also going to do is I'm going to change this to ball. Now, if you recall in one of the earlier videos, what we did is we looked on an empty object. So let's say I disable the sprite renderer, which is a component that lets us see the ball as the sprite, the circle. So if I turn it off, now we can no longer see it, but it's still there. We can see here the position. When we look on the scene, we can see the object. And if we start to change the X, we can move it around and the Y move it around. Though we can't see the ball itself because the sprite renderer is disabled. But if I re-enable the sprite renderer, we can see the ball in the exact same location. So this is nice, but how is that connected to using physics? So in order to create physics, we actually need three things. The first thing is the rigid body, which is basically like the physics object. The second thing is the collider, or you can think of it as a physics shape, which is the shape that determines how the field is going to react. And the last thing, so there are three things. The last thing is the logic, which we're going to talk about a bit later. The logic is actually the code that we use to handle the situation when one object collides with another. So let's have a look. So we said the first thing we need for physics is like the body, the rigid body, the rigid object. So I'll look for it. And you can see I have a rigid body and rigid body 2D. Because we're working on 2D, I will select the rigid body 2D. Oh, by the way, I did all this while playing, so I need to do it all again, so I'll do it real quick. So we have 2D object, sprite, circle, send the color to yellow, make it a bit smaller. I'll use the shift to keep the ratio, and I'll add the rigid body 2D. Okay, so as you've seen, the minute I put the rigid body 2D while the game was playing, it fell down. That's because this rigid body has here, okay, it has a mass, but it also has gravity scale. Gravity scale is the number that defines how much the body is being drawn to the bottom. Okay, so we have the gravity scale. So we want to now do a few things with it. So we have the rigid body. Now we also want it to have a rigid shape. So we look for collider. And there are different types of collider. We'll go for the circle collider 2D. And it's quite hard to look, but if we look closer, you might see that we have here some kind of green circle just around the shape. Now if I'll change it a bit, like I say, edit collider, and I'll pull this one to the right, now you can see it, and it can be smaller or larger than the actual ball. Let's put it inside of the ball. So the collider is used for us for the physics to know how to handle collisions. And there is a reason why we use certain colliders like circles, maybe a box collider, but we will have a look later. So now we have the collider and we have the gravity scale, so if we press play, it would just fall down. Now you might be wondering why the ball did not stop at the pad. I mean, the whole idea of the game is using the pad to hit the ball back up, right? Back to the top, trying to hit bricks. So why does the pad don't stops the ball? And the reason is the pad itself is not a physical object. Because if we look on the pad, we can see the transform, the location, the position, the rotations, and the scale, and the sprite renderer, which defines how it looks. And we also have the scripts. Remember, we have the scripts that enable us to take it to the right, take it to the left, etc. But what we do missing is everything that is related to physics. So let's start with that. So I'll start again with the rigid body, 2D. And I'll go and add a collider. And this time I will pick a box collider 2D. Okay, now if we'll look at it, okay, and we'll look at box collider again, it's because these are shape and sprite we created from Unity, they're in the exact size of the box which is held inside. Okay, so this is the size of the collider we take, whether this is a rectangle collider, a box collider 2D, or a circle collider 2D. So now it has a collider and it has a rigid body. So now we can expect that when the ball hits the pad, something is going to happen. So let me ask you, what do you think will happen now when we play the game? How will they act? Let's have a look. So let me just press the play. And, whoa, both of them fell down. I knew that was going to happen. And the reason is when we work with rigid body, we have to define how that physics body is going to act. So we already said it has a gravity scale of 1, and that called it to fall down. Now I want to change that, but actually I want to change a bit the whole type of the object, because this is what is called, the body type is dynamic. Dynamic means that it is affected by physical force like gravity, or maybe if the ball like hits it. So we'll try two things. We'll later try changing the body type, but first of all, let's look what happens if we just remove the gravity scale and turn it to 0. Okay, so let me play that. So this was quite interesting, right? Let me do it again. Let's just take the pad a bit higher, and maybe the ball as well, so we can have a look on how it acts. And you know what, I'll move the ball just a bit to the right, and let's just play. So you remember, both of them are now dynamic, but only the ball has gravity scale. But when it hits the pad gets the energy from the ball. It gets an energy that's going down, a velocity that's going down. It also gets some rotating power, rotating force. That's why it acts the way it is. And for the pad in this game, we don't want it to act this way. Okay, we want the pad to be stable and the ball to act as he is a dynamic object. Okay, a physics object that is affected by the physics power. So how can we change that? So let's take the pad. By the way, I left the circle, not the ball. Let me just change it for a minute. That's great. And let's take the pad now. And we have the pad and we have the rigid body, so let's change it. And here we have a few things. We have dynamic, kinematic, and static. And I'm not going to talk about the differences. Okay, there's a difference about how they are handled with the physics power. But let me just tell you that dynamic is built to use and react to physics power, and kinematic is affecting the physics power, but it is not itself affected by the physics power. So you see that the kinematic has a lot less things in here, right? It has a lot less variable, and you can see it has no gravity scale. So let's see how this affects our game. So if we play it now, and the ball goes down, hit the pad, okay, it just stops there. Now this is much better because the pad is there, and look, here I can still control it with the arrows, which is great, and the ball fell down, and the pad totally is not affected by the ball, but is affecting the ball. That's very interesting. But if you notice, there's something that you might not have expected. I mean, the ball hits something, wouldn't you expect it at least to jump a bit? And that is correct, and the thing is that there are a lot of physics definition, you know, that we kind of take for granted in the real world. But think of it like this. Let's say we have two balls. We have a like bouncy ball, and we have a ball that is like a bowling ball. So you drop a bowling ball on the ground, and maybe if it's a really big fall, it would jump just a bit. Okay, but if you drop an elastic ball, it would jump quite high. So the same things go inside Unity. We have to make the definitions for it to work the way we expect. So in order to affect the way the ball works, we actually need to give it a physics material with the parameter needed for us to configure the exact behavior that we want. So let's see how we do that. So we go to the project. The project is like our directory. It has all the things we worked with. And currently we just have the scenes, the folder of the scene which will have the sample scene, and the scripts, the pads that help us control the pad. And now we'll I'll right click, and we want to create, so go to create, and we want to create a physics material, but we want 2D physics material, so I think we have to go here, 2D, and physics material 2D. Great. The physics material 2D and 3D has a bit of different attributes. So the 2D physics material is a very simple one. It only has friction and bounciness. So let's just change it. So I want first of all, I'll call it ball material. And let's change the friction to 0, which means it will not be affected at all by friction. At least it wouldn't. I'm not sure if it means the ball wouldn't have friction. I believe so, and not that it wouldn't be affected by other object friction. We'll probably have a look on it later. And there is the bounciness that we'll actually want to be at 1. Bounciness of 1 actually, it means that the ball is supposed to get the same exact energy. Like if it hits the floor, it will keep the same energy, and it should go to about the same height, more or less. I'm not a big physics geek. So let's have a look. Let's just try it. But of course, we created the material. We still need to adjust. So we'll take the ball, and we want to add the material. Okay, let me just stop it here. Okay, so there's the ball, and we want to add the material. Now there are actually two places. We can either put it on the rigid body or on the collider. And you might ask, why do we have these two options? And the reason is, you can actually think about it. Let's say we have some kind of a ball that we want that one side to have bounciness and the other one doesn't. Okay, so I like to play with this. So we can place two different colliders with different materials. Okay, and this is a bit, maybe too much information for this stage. For now, we just take the ball material, and because I want the whole ball to act the same, I'll put it right here on the rigid body, and let's just run it and have a look what's going on. Okay, so run it, and we see the ball jumps. It's actually, you see it keeps jumping on to the same height. I can still move it, still move the pad. Okay, and let's try something. Yeah, and fell down. So this is actually pretty nice, right? So what else? I think for now we'll finish with this video. So we have a nice look on how to use the physics. Really simple. We talked about three things. We talked about the body, okay, the physics body, the rigid body 2D, which is basically kind of like the object. Okay, you can think of like any object in Unity has the transform. So the rigid body is kind of like the basic configuration of a physics object, and it's kind of like the transform for a rigid for a physics object. So this, we have the body. Okay, so this is like the general definition. Then we have the collider. We can have multiple collider. And the third thing we said is we're going to have the behavior, the logic, which will be inside the code. So it's actually how to write the code that will decide what happened. For example, if the ball would hit a brick later on. Okay, but for now, I think we're pretty good. So I'll finish this video and we'll continue in the next one. So thank you very much for watching. I'll see you in the next video.